Today we're going to talk about how to draw Lewis structures for compounds. This can be used nicely in conjunction with 10 molecules you need to know. There's specifically 10 molecules you're responsible for being able to draw the Lewis dot structures for. Some people find it really helpful to have kind of a how-to on where these structures came from. Some people would prefer to just memorize them, and that is completely up to you. So whichever one you kind of decide works better for you is totally fine with me, but it is nice to have a little background on where these come from. So the steps to this are in your packet. I also have them up here so you can kind of follow along with them as you go. So the first example we're going to do is O2. The first thing that we actually need to determine is how many electrons are needed for each O2 to feel like it has a full valence shell. Most atoms are full with 8 valence electrons. Some, remember, especially hydrogen will be the one we run into, that only needs 2. So we have 2 atoms of oxygen. So there are 2 of these atoms. And each one of them wants to feel like it has 8 valence electrons. So 2 times 8 is 16. So we need to feel like we have 16 valence electrons total for each of these guys to have a complete octet. My number of available electrons, I'm simply adding up the valence electrons in each atom. So I have 2 atoms of oxygen. I go to my periodic table. Each oxygen has 6 valence electrons. 2 times 6 is 12. Step number 3, I'm going to figure out how many electrons are to be shared. This is going to predict my bonds for me. My shared electrons will be my needed electrons minus my available, or in this case 16 minus 12, or 4. I'm sharing 4 total electrons. Each bond is comprised of 2 electrons. So my number of bonds will be my total shared electrons divided by 2. Last thing I need to do, steps 5 and 6 are a little bit more complicated and do involve some outside knowledge. So I have 2 oxygens. My best bet really is to put those 2 oxygens next to each other. And we'll talk a little bit more about shapes and how you get a little bit more used to this. So I have 2 oxygens. Between them, I'm going to put 2 bonds. So that uses up the 2 bonds I solved for in number 4. The last thing I need to say is, do I have any unshared electrons, which I'll just call UE. Unshared electrons are found by doing your available minus your shared. So what this really means is we have drawn right now in this picture 4 electrons in that double bond, but our available number of electrons is 12. So we actually have to show 12 electrons in this picture. So for my unshared electrons, those are just kind of unpaired or paired electrons that are kind of hanging outside of the bonds. My available is 12 minus my shared, which is 4. So I'm going to have a total of 8 unshared electrons. Best bet usually is to do these really symmetrically, and keep in mind each of these oxygens wants to feel like it has 8 valence electrons. So right now, if I'm looking at the oxygen on the left, he feels like he has 2, 4. So he needs to have 2 more sets of electrons. So 1, 2, 3, 4. So half of my 8 electrons will go there, and half of my 8 electrons will go here. Nice check at the end is, do each of my atoms have 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Another nice check is, did I draw the proper number of electrons? So I cannot draw more than 12 electrons. That's all I have to bring to the table here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I drew 12 electrons. Good to go. We wanted to do the same thing for water. First, we would do our needed. I picked water because it's got hydrogen in it. I have 2 hydrogens. So for my needed, I have 2 hydrogens, and each of them can only fit 2. So hydrogen's an exception to that rule of 8. And I have 1 oxygen, which can fit 8 valence electrons. So I need to show a total of 12 valence electrons in my picture. My available electrons, I have 2 hydrogens, and each one of them has 1 valence electron. I have 1 oxygen, and it has 6 valence electrons. So this gives me a total of 8. So I'm allowed to draw 8, and I have to make them feel like they have 12. by the way I arranged the bonds so that they're sharing. The number of shared electrons will be 12 minus 8, or 4. Each bond is comprised of 2 electrons, so 4 divided by 2 is 2. Now, this one you have to have a little bit of knowledge to lay out. You do need to kind of have an understanding that water is actually a bent molecule. So the hydrogens are actually kind of down in this weird sort of bent configuration. I'm going to show 2 bonds. Now I need to figure out how many unshared electrons I have, which is my available minus my shared, or 8 minus 4. So I'm going to have 4 unshared electrons. Now you might be like, how do I know if I put them on hydrogen or oxygen? It's a great question. Hydrogen, remember, feels full with 2. So if you look at each of these hydrogens, this guy right now can count those 2 electrons. This guy can count those 2 electrons. They don't need to feel like they have any more. So I don't put any more electrons on them. Those guys are good to go. On the other hand, oxygen feels like it has 2, 4 electrons. So by putting those 4 electrons there, if I go ahead and count 2, 4, 6, 8, oxygen feels full with 8, 2, 2. Each hydrogen feels full with 2. And then I want to check that I didn't draw too many. I'm allowed to draw a total of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And I'm good to go. Again, this will tie into 10 molecules you need to know. A lot of people find memorizing them easier. A lot of people find a combination to be really, really helpful.